All right, we're going to start this section talking about intermolecular forces. We're going to start pretty basic and then we'll get to some more specifics in later videos. But let's set up the question. Why are we studying what we're studying in this chapter? You may recall that matter can be in a solid, liquid, or a gas phase, and that solids, liquids, and gases are different based on how their particles behave. In a solid material, we see that the particles are very close together. They're held fairly rigidly. In a liquid, the particles can be further apart, but more importantly, they're allowed to move. They actually move past each other. That's why liquids flow. They'll take up the shape of the container and so on. And in the gas phase, the particles are very far apart, relatively speaking. They're also moving very rapidly, and so we see them bouncing around the container and off of each other with inelastic collisions, and this gives rise to the pressure of the container. So the question is, why would a type of matter, a substance, either a compound or an element, why would it differ? Why would sometimes it be a solid, sometimes it be a liquid, sometimes it be a gas? What is causing that to happen? We can think of an example. Let's take water. Water is a solid under certain circumstances, a liquid under others, and a gas under different circumstances. And you're probably screaming at your computer screen, it's a solid when it's frozen as ice, when the temperature is below 0 degrees Celsius. It's a liquid. That's typically what we think of when we think of water, but the H2O molecules are still H2O molecules in the solid and the liquid, and this is between 0 and 100 degrees Celsius that it takes on the liquid shape, the liquid form, I should say, and water becomes a gas. It's still H2O molecules, but those molecules are in the gaseous state when you are above 100 degrees Celsius. So changing the temperature on this one substance, this water, H2O, this pure substance, makes the difference as to whether or not it's in the solid, the liquid, or the gas state. But why, again? Well, one thing we know is that as you increase the temperature, you increase the kinetic energy of the particles. We talked about this in the kinetic molecular theory. As the temperature gets raised, the particles have more energy of motion, the kinetic energy. So you might think, well, below a certain temperature, the particles don't have enough energy to move around much. That's why they're solids. You raise the temperature, now they can move around a little bit more. Now they're liquids. You raise the temperature even more. Now they can go into the gas phase. This is where they have the most kinetic energy, therefore they're going to move apart. But if we think about it the other direction, what on earth would cause gaseous particles of water that are very far apart and moving rapidly, what would cause them to go into the liquid state? If you lower the temperature, they're going to slow down, but why does slowing down mean that they become liquid? Why does slowing down mean that they would go from a liquid to a solid? So we want to investigate what's going on to cause these phase changes, these phase transitions. Here's the bottom line. What causes these phase transitions, if you will, are the intermolecular forces. The intermolecular forces govern the phases of the substance. Intermolecular forces are like, if you think about the word an interstate highway, intermolecular forces are forces between molecules. Now we actually could be talking about atoms instead of molecules in an atomic sample or an elemental sample. So we can generalize this to say that intermolecular forces, even though it uses the word molecular, it's forces between the particles. In other words, if I look at my samples here, there are forces of attraction between these two particles in this sample of solid and forces of attraction here and here and here and so on. If we move over to the liquid sample, there are forces of attraction keeping these two particles close to each other. And in the gas phase, we still have forces of attraction between the particles, and you might begin to see that my intermolecular forces, my forces of attraction here in the solid phase must be stronger because it's keeping the particles close together. a little weaker in the liquid phase because now, although my particles are close together, they're allowed to move past each other. And in the gas phase, this is where my intermolecular forces are the weakest because they're not held close together. They're allowed to get far apart. So whatever this attraction is between the two particles must not be very strong because these particles are able to get far apart.